When you think about chemistry, odds are that your brain comes up with images of people in lab coats working in kind of a sterile laboratory environment with beakers and catalysts and compounds. But how on earth do you actually perform chemistry experiments when you're talking about objects billions of miles away? Astrochemists don't have the luxury of being able to take samples of the things that they're trying to analyze. And you're going to learn about the really fascinating way that the chemistry of space is actually based entirely on what can be observed. So we're going to talk to one of the scientists that's working with the James Webb Space Telescope program to find out exactly how she and others like her have created chemical profiles based entirely on what they can see. While visiting NASA's Goddard Space Flight Center, we got scientist Stephanie Milam to help us understand how all of this chemistry and science of space works, and to get a sense of how learning about the chemistry of far distant space and studying the science of what we can see far away can really impact life right here on Earth.
My role for JWST is to make sure that we have this massive, huge astrophysics observatory that looks for the farthest stars in the universe and try to point it at the fastest moving, brightest objects in the sky, which include the bodies of the solar system. So instead of going to a laboratory and using beakers and microscopes and studying chemistry in a lab, I get to use telescopes or space observatories to study chemistry in space. So I look for different molecules, I look for signatures of them, and by studying the different molecules and their different abundances and temperatures, we actually learn about the chemistry that's happening in space. So the tool I use, as opposed to wet chemistry or high analytical instruments that most chemists use, is I use spectroscopy. So every molecule has a fingerprint, just like you have a distinguishable fingerprint from me, so does every molecule. So what we do is we're studying the fingerprints of these given molecules in different environments. So once we have the full fingerprint, we know exactly how much of that molecule is there, how hot or cold it is, whether it's in a solid phase or a gas phase, and then we can actually put all together all the different fingerprints and sort of build up a chemical network and see what's actually going on. But with JWST, we can do basically everything in the solar system from Mars on out. That's just because of the sun shield. We can't point towards the Earth or the Moon or Venus or Mercury. But everything from near-Earth asteroids to comets to the ice giants to the gas giants, they're moons, we can see volcanoes on moons, we can study atmospheric effects in the outer planets. We're even going to get to observe Pluto, just as New Horizons just did, and its moons. What I'm hoping to achieve with this mission is we can do very detailed compositional studies that we can't do from the ground. And actually, one of the best objects for JWST are comets or icy bodies in the outer solar system. We just don't really have access with any observatory here on the ground. Hopefully, we'll be able to determine what the composition of these small icy bodies are. They're actually the relics of when our solar system formed. So they're considered little pieces of history that are frozen, and every once in a while they happen to fly close enough to us that we can observe them from the ground. But with JWST, we can actually observe them in their own environment, sort of at a very distant, out beyond Pluto and Neptune. So getting the composition of those will really tell us what was happening whenever our solar system formed. And if we can get the chemistry of that and see if that chemistry is ubiquitous across the universe or the galaxy, that means that we have the same organic chemistry here in our own solar system as we do in other solar systems.
Now you know about the amazing stuff that you can actually discover simply by looking at objects far, far distant from our world with an object like the James Webb Space Telescope. So if you're interested in experiments and science that's like this, you can absolutely follow us at now.howstuffworks.com, because we're going to be following the work of the James Webb Space Telescope as well as other cool space science. We hope you join us.